This lesson is on multiplying polynomials. Multiplying polynomials can be essentially done using the distribution property. The simplest example of multiplying polynomials is by multiplying a monomial by a monomial. We have seen this before when we learned about rules on combining exponents. So let's take a look again here. If you recall, something like this, negative 2a cubed times 3a squared, was done by multiplying everything together and therefore multiplying your numbers first, which gives you negative 6, and your letters. And remember, when your variables are multiplied, your exponents are combined using addition, because a cubed times a squared essentially gives you 5a's multiplied together, which is a to the 5. So let's take a look on expanding that by taking a monomial and multiplying by a binomial. This is the distribution property. And to review the distribution property, think of it in this way. Say you have three groups of a and 2. So if you draw that out, you have a and 2, a and 2, a and 2, and therefore you actually have three groups of a and three groups of 2. Therefore you're actually multiplying the monomial by each of the binomials separately to distribute and get rid of the bracket. This gives us 3a plus 6. Now we can take that same idea of distribution and extend it to multiplying a binomial by a binomial. So in this case, we have a plus 3 times a plus 2. So we take every single term of the first binomial and multiply by every single term in the second binomial. To write it out slowly, this could be seen as taking a times a plus 2 and 3 times a plus 2, which then gives us a times a, which is a squared, a times 2, which is 2a, plus 3 times a, which is 3a, plus 3 times 2, which is 6. And then combining like terms. So essentially you're distributing and then combine like terms. In this case, our like terms are our degree 1 components, which are 2a and 3a, which give us 5a, the a squared stays, and plus 6. There's our final answer. This step can be omitted when you're showing your work. You can essentially do it by drawing it this way, saying, I'm going to start with my a, and I'm going to multiply both my a and my 2, and then I'm going to start with my 3 and multiply both my a and my 2 as well. That way, every single term gets to partner with every single other term, and they can have a barbecue. So let's extend that and continue on to bigger polynomials. So the same idea goes for this example here. We have 3 terms by 3 terms, so 2 trinomials. These could be even bigger. As long as we stick to the same property, we will succeed. So first term is going to multiply by all 3 of the terms in the second polynomial. So let's get that later on. X times x gives us x squared. X times 2y, and they're both positive, so it's positive 2xy. Notice in terms, usually we use alphabetical order. So plus 2xy, and then x times negative 3 gives us negative 3x. The next layer I'll do in blue, and that will be multiplying every single term by y. So because I don't have enough room here, I'm just going to keep writing it a little bit over here. So y times x gives us positive xy, and then y times 2y gives us positive 2y squared, and y times negative 3 gives us negative 3y. And let's do the last layer in green, multiplying everything by 2, by positive 2. So that'll be positive 2 times x is 2x, positive 2 times 2y is positive 4y, positive 2 times negative 3 is negative 6. Now this could be all written in one row. It's just space on the page here. So after we use the distributive property, we want to combine all our like terms together. So let's combine any like terms. We have an x squared, and there are no other x squared terms. Okay, now let's take a look at x terms. And in this case, because we have more than one variable, it's difficult to decide on an order, so don't worry too much about your order. So negative 3x plus 2x gives us negative x. And then let's do our xy terms. 2xy plus 1xy, and that's it. So 2xy plus 1xy is positive 3xy. And let's look at our y terms. So we've got positive 4y minus 3y is positive 1y. We've got this y squared term that we haven't included yet, so positive 2y squared, and minus 6 is also included. We got this beautiful answer here. Notice you could have rewritten this in other ways. You could have kept the squares first. There's no set way of writing this in this case. Alright, and let's take a look at some special cases. These special cases will be coming up over and over again, and they will particularly be very important in the next unit when we begin to factor. So try your best to focus in on this format and take note of the patterns that exist within expanding things like differences of squares. So you'll see why this is called the difference of squares as soon as we expand this question. So let's go ahead and just distribute. So a times a gives us a squared, a times negative b gives us negative ab, b times a gives us positive ab, b times negative b gives us negative b squared. What happens to our middle terms? Negative ab plus ab, gone. That's zeros out. You're left with a squared minus b squared. And therefore, that is why it's called the difference of squares, because you've got a difference of two squares. This format will be very, very important in the future. So take note of it, and note that if you have two squares that are subtracted from each other, it can be written as taking the square roots of them, meaning a and b, and multiplying their sum and their difference together. Another common pattern that is seen is by taking a and b, two terms, added or subtracted, and squaring the whole thing. Now, a common error with this is to say, oh, this is just equal to a squared plus b squared. Well, let's take a look. Would it be? Let's take an example. 2 plus 3 squared, is that equal to 4 plus 9? Well, this would have been 5 squared, which would have been 25. Is 4 plus 9 the same as 25? Certainly not. So remember, when you're squaring a bracket, you're multiplying the bracket by itself. meaning we're going to need to distribute all of this and see what happens. So the first step is a times a, then a times b, and then a times b again, and then b times b. So in this case, because we have not different signs in the middle, but the same signs in the middle, our middle terms actually double up every single time. So that gives us a squared plus 2ab plus b squared. You'll notice if the middle sign was a minus, so say this was a minus sign here, these would be both minuses, and that would give us these terms to be different. Your a times your negative b would be negative ab, and your negative b times a would be a negative ab, which would be then negative 2ab. And then negative b times negative b would then also be positive. So essentially, what we can say is that anytime we have a plus or minus b squared, we're going to have the first term squared, then we'll have plus or minus, depending on what this was in the center, twice the first times the last, which was double the middle term, and plus the last term squared. And there's another pattern. So these two formulas will be relatively important in our future. Let's take a look at some examples of multiplying polynomials. First example, we need to distribute. So first times first term, first times second term, and then first times last term. 2x times 3x squared is going to give us 6x to the 3 because we're adding the exponents, we're multiplying the numbers. 2x times negative 5x will give you negative 10x squared. And feel free to say it to yourself, just like I'm saying it. 2x, positive 2x times positive 1 gives us positive 2x. And there are no like terms, we are complete. Next question, we've got two distributions to make. X squared times 2x gives us 2x cubed. X squared times 1 gives us positive x squared. Now this here is a negative 1. Remember, if there's nothing there, you're distributing a negative 1. Negative 1x squared, and then negative 1 times negative 5 is positive 5. Are there any like terms? The x squared terms are like, and they actually cancel out, leaving us with 2x cubed plus 5. The x squared term is actually just a 0x squared, which in this case we don't need to write. Let's take a look at the next example. 2x times 3x squared, both positive, giving us positive 6x cubed. 2x times positive 4x gives us positive 8x squared. Positive 2x times negative 5 is negative 10x. Negative 1 times 3x is negative 3x squared. Negative 1 times positive 4x is negative 4x, and negative 1 times negative 5 is positive 5. Now that we have it expanded, we can collect like terms. So our cube term is first, and it is alone. There's nothing else to combine with it. Our x squared terms are next. 8x squared minus 3x squared is positive 5x squared. And negative 10x minus 4x is negative 14x. The positive 5 is still there. And that is complete. Remember to pause the video and try these on your own before I complete them. Next up, let's take a look at a few more examples here. In this one, we have a few options. We could distribute the negative 3a into the first bracket and then distribute both brackets, or we could combine the second two brackets and then distribute the negative 3 after. I think that is a little bit easier, but it really essentially doesn't matter. So you can try both ways and see if you get it both ways. 4a times 1 gives us 4a. 4a times negative 3a is negative 12a squared. 4a, oh, there's no third term. Negative 3 times 1 is negative 3. Negative 3 times negative 3a is positive 9a. And we've expanded those two brackets. Now we need to multiply in the negative 3a. And notice you could combine like terms first, or you could do that later. So you have several options in this example. Try it on your own in different ways and see if they all come to the same answer. Negative 3a times 4a is negative 12a squared. Negative 3a times negative 12a squared is positive 36a cubed. Negative 3a times negative 3 is positive 9a. Negative 3a times 9a is negative 27a squared. So let's combine any like terms here. We've got our cubed term, which should go first, 36a cubed. And you really want to code them so that you don't forget terms. It's easy to forget terms when you're doing this. Our a squared terms should come next. So we've got negative 12 minus 27 will be negative 39a squared and plus 9a. And this is the fully expanded form. The next one looks like one of our special formula examples. So you have two choices here. You can either follow the format of the pattern that we showed you in the formula in the previous slide, or you can do it by hand. So most people like to do it by hand for a while, but after a while you start noticing that every single time you're going to get the first two, which gives you the first term squared, 4x squared, and then the middle terms are going to double up. And notice they're always going to be the same thing. 2x times negative 3y is the same as negative 3y times 2x, which gives you negative 6xy, but then negative 6xy again. So notice if you multiplied 2x times negative 3y, that would be negative 6xy, and double that, that would give you negative 12xy, which is your middle term. And then your last term is always also squared because it's the same, so you'll have positive 9y squared. Essentially, that leaves you with the first term squared minus, in this case because it was a minus, double the first times the last, which was 12xy, and plus the last term squared. So, or you could have remembered that a plus or minus b squared is the first term squared plus or minus double the first times the last plus the last term squared, and followed the formula. So if you have 2x minus 3y squared, you would be getting the first term squared, 2x squared, plus or minus, in this case it's a minus, 2 times the first times the last, and plus the last term squared, which was 3y. Notice that gives you 4x squared minus 2 times 2 times 3 is 12xy plus 9y squared. Either way, you get the same answer. The next one also looks like a special case because the first and the last terms of each bracket are the same. However, in this case we have a plus and a minus, whereas here we had the same sign. Remember, when the signs are different, the middle terms will cancel out. So the easiest way is to use our a plus b times a minus b, knowing that that gives us a squared minus b squared, the difference of squares formula. We can use that to our advantage. We can say, well, this is my a, this is my b, this is my a, and this is my b. My a is 2x, my b is 3y. So essentially I'm going first term squared minus second term squared, giving me 4x squared minus 9y squared. Done. So you almost don't need to write any of this if you have come to terms with this pattern. However, if you're just starting out and you really just want to convince yourself, you can go ahead and distribute. 2x times 2x gives you 4x squared. 2x times negative 3y gives you negative 6xy. 3y times 2x gives you positive 6xy. Notice they will cancel out. And the last two terms give you a negative 9y squared. Middle terms cancel out, and you're left with 4x squared minus 9y squared. This is the difference of squares. Let's take a look at some more examples. These are a little more complicated. Feel free to try them on your own first and then check your work. Alright, so here we got to expand. 2 times 1 gives us 2. 2 times x gives us 2x. Negative 3x times 1, negative 3x. Negative 3x times x gives us negative 3x squared. Now, because we have a negative, we want to place the negative, but when you're opening the next set here, it's important to open up brackets because this negative will also be multiplying and changing all of these signs. The other option you have is to make this a positive and change the signs of one of these brackets. Although I think this way is a little more clear and a little easier to not forget about. So let's try this out. X times 5x gives us 5x squared. X times 6 gives us 6x. Negative 3 times 5x gives us negative 15x. Negative 3 times 6 gives us negative 18. So let's write this all out again. And get rid of this bracket by multiplying everything by a negative, which changes all of the signs. Now we can look for like terms. So let's start with our highest degree. We've got negative 3x squared minus 5x squared giving us negative 8x squared. All our x terms, it's a bunch of them. So we've got 2 minus 3 minus 6 plus 15 x's, which is positive 8x. And we've got our positive 2 and our positive 18, which is plus 20. And that is simplest form, expanded form. Last example, here we actually have no distribution in the first term. This is all multiplication because each of these are monomials. So essentially we're just saying negative 3 times x times negative 2 times x squared times negative 4 times x cubed. So let's multiply our numbers together. Negative 3 times negative 2 is positive 6, and 6 times negative 4 is negative 24. X times x squared times x cubed is x to the power of 6, because 1 plus 2 plus 3 is 6. Now we do the same thing. We open up a bracket for this distribution before we put the negative in so that we don't forget to change the signs. It's a very common error to not write this bracket and then not change the signs, so be careful here. Now we could distribute all of this, or we could notice that this is actually a difference of squares. So I can let you convince yourself that this is, in fact, x squared minus 1, because it's first term squared minus last term squared, because this is the difference of squares pattern. This gives you negative 24x to the 6 minus x squared plus 1, because you have to change the signs because of this minus. And that is complete because there are no like terms.